Okay, so this video is going to talk about something that's probably not the most thrilling thing in the world, but is pretty important. So what we've got here is we're going to be talking about hole types and then how we note those in a dimension drawing. So here I've just got an example of 3 different hole types that are created in Onshape. So we'll talk about each of these different types of holes and how they're denoted. So the first question we've got here is just the difference between a through hole and a blind hole. So a through hole, which you're going to see notated with this capital THRU, goes just all the way through the part. Pretty simple. A blind hole is a hole that is only going to go some distance into the part. You're going to have to set that distance. It's blind because you cannot see through it. You'll notice here that the blind hole has a pointed bottom because that's usually how you're going to create those, with a drill of some sort that has a point on it. So our first type of hole we've got to discuss here is just a simple, straightforward hole. It's going to be defined by its diameter and its depth, or using the through notation here. In Onshape, if you want to set the diameter and the depth directly, you're going to want to set it to a custom hole. We'll talk later about what the actual standard hole sizes are. And then right here, you'd get the option to set it as through or blind. And if it's blind, it'll come up with another number to show you the depth. Next up, we've got what's called a countersink hole. And so if any of you've seen screws that have like that tapered bottom of the head, a countersink hole is just designed to fit that tapered head into the part so that it doesn't stick out above the top of it. So it sits flush with the top of the part. The only dimensions that you're going to have to add on are going to be in addition to the diameter and depth of the hole, are going to be the diameter of the countersink, which is right here, 1 inch, and the angle of the countersink. 82 degrees is pretty much the standard, so you'll probably never change that. Then we've got what's called a counterbore hole, and this is different because it's not angled like this. It's actually got a flat bottom. So if you were sticking a normal bolt into that hole, that would sit nice and flat, and it would have a nice surface to press against. Whereas the countersink is kind of like wedging itself in there. So you'd have added dimensions here for the depth of that counterbore, how deep this little piece of the counterbore is, and the diameter of the counterbore itself, which you're seeing right here. So each of these hole types can be either a through hole or a blind hole. Through holes, again, just go all the way through. Blind holes have some sort of a set depth. As you can see, I'm setting the depth there. Once it's changed to blind, you can change the depth. So we've also got a few more advanced options here. This is kind of talking to you about the idea that all of these hole types can be sized automatically for a standard bolt. If you are going to go and just use a normal bolt, which everybody does because no one's going to take the time to design their own bolt, this program has all of them already built in. And so you can see if I want to use a ANSI standard, which is what we use in the United States for the most part, and I want a hole that is designed so that my bolt can go in easily. That's, in other words, a clearance hole. It'll fit in, just slide right in. For a 1/2 inch bolt, Onshape automatically knows that I want a hole that has a diameter of 0.531. And you can actually change the fit. This one is free. That's the loosest fit it'll be. You can change it to normal or close. A close fit will still slide in nice and easy, but it'll be a lot tighter fit, so it can't move around as much. It'll also automatically size the counterbore or countersink or whatever you're using for the head of the bolt to fit in, because all of that is standardized. And this will work for metric bolts either way. So if you change it to ISO in the standard, International Standards Organization, then you can select things like a metric bolt, an M10. So an M10 is 10 millimeters in diameter, but they're making the diameter 11 millimeters so that it'll fit in nicely. Then we've got things like tapped holes. We will talk more about this a little bit later on. But a tapped hole is going to allow room for threads to be cut into this. Now, Onshape doesn't show the threads. I have a picture later on of one that does show the threads. But one thing I want you to notice here, if I make a tapped hole for a 1/2 inch bolt, what you'll notice here is the diameter is actually less than a 1/2 inch, because that leaves room for me to actually cut the threads in, and then it leaves room for 75% engagement. So the only way threads work is if they actually have an area to lock onto. And so the hole actually has to be cut smaller than the bolt so that you can actually have that thread engagement. And then the last thing here is just our documentation. Holes are going to be dimensioned with what's called a hole call out. And that's what this thing is right here. You'll always want to include a center mark. And then in a real application of this, you need to dimension and tell me where to put the center mark at. How far is it from one side? How far is it from the other? But simple holes are going to be fairly straightforward. Of course, they're simple. It's going to give you a diameter and it's going to give you a depth. In this case, I'm just using the through symbol. This diameter symbol will come up automatically when you use the hole call out, and we'll talk about how to do that later on. Right now, I just want you to be able to read these. So this is a 1/2 inch hole that goes all the way through. Then we've got countersink holes. They're going to have the same information to start off with. This is a 1/2 inch hole that goes all the way through, but now it uses another line here. The second line gives you this little V shape. That is the symbol for countersink. Again, countersinks are those angled ones. It tells you the diameter of the countersink, and it tells you the degree of the sloped walls. And then finally, we've got counterbore holes, which look very, very similar. You've got your diameter and your depth. You've got your counterbore symbol. Looks just like the actual head where the head of the bolt goes through. And now instead of a degree, you just got a depth because it just goes straight down and over. From there, we talk about the difference between blind and through holes. Remember, blind holes go all the way through. Through holes, of course, go all the way through. Blind holes do not. So like before, our through hole just says our diameter and through. Our blind hole says our diameter and then our depth. This little symbol here means depth. And then the last thing is we talked about threaded holes earlier on. Onshape does not show these threads. I think you saw a picture of one where I was making a threaded hole and it did not show. A CAD program like this usually doesn't show threads, or if it does, it's not actually there. It's just a picture of the threads. To make the threads, you've got to do some more advanced things. But the only time you'd ever want to actually make the threads in real life would be if you were going to 3D print the thing. So it does include all of the information that someone would need to make the threads afterwards, though. And that's how normally this would work. Someone would drill the hole in there, look at your documentation, and then decide what type of a thread to put on it. So here you've got some examples of threads. The first one here is an isometric thread. So you've got a diameter of 10.3 millimeters all the way through. And we're going to thread it as an M12, 12 millimeter bolt. So a 12 millimeter bolt has a 10.3 millimeter hole that gets drilled in it. And this is just saying it's thread pitch. And this is all the way through. So these two things here, this M12 by 1.7 and this 1/2-13, are giving you the same information in two different ways. This information is threads per inch. And this is kind of the exact opposite. This is like millimeters per thread. So they do them differently, but this is the same exact thing in a standard inch. So for a 1/2 inch bolt, we're going to use a diameter of 0.433. And then this tells the person making the part what type of threads to put in. It's a 1/2 inch bolt, 13 threads per inch. And that's pretty much holes. Next week on Monday, I guess, yeah, everybody's Monday here. We'll take a look in Onshape and how to make this thing. And I'm going to actually just have you start off with basically just making this drill block, I guess you'd call it, using, doing a standard simple hole, a countersink, a counterbore, trying to add some threads, all that kind of stuff. I'll have you play around with the blind and through and everything else. So that'll probably be like 8 holes total you have to put in a block, and I'll give you a little picture of what you have to do. But that's kind of what's coming up. So have a great weekend, and I'll see you next week.